trying to go live. It's alive.
That's
Yes. Can confirm. It's alive.
okay.
I I don't even need people to confirm my existence anymore. YouTube has made like the new like have you spent any time using the new YouTube live? Do you spend any time in YouTube live at all or is it all Twitch? Okay. Well, they've completely redesigned the
Yeah.
actual back end for YouTube, and they've made a much better, much smoother streaming system. The only problem with it is it's completely hidden, and I'm sure Susie has smashed her head against this many times trying to find it. Like you've got to go into a really kind of obtuse way of actually finding the event and making the new events. Like the actual interface for doing it is great, like much more streamlined. But
Hmm.
for everybody else, like just for trying to find it and set it up, it's just still just misery.
That is sadness.
Yeah, yeah. Although Twitch, they
Not
made theirs more. Like every time I try to do a new, like I'm sure you just click stream and then you're live and you don't even think about it. But for me,
right.
I'm resetting it up every time, and I lose where all the buttons are every time. And they don't make it very obvious either. You've got to like go into a bunch of subsections and find it. So anyway, streamer problems, right? Am I right?
Yes. Yes. And I will admit, I by using Wirecast, which I know you
Yeah,
hate,
yeah. It should.
I've made all these problems go away for myself.
I'm sure you have. I'm sure it's got some fancy. Maybe I'll like I own a license, so maybe I'll upgrade it.
Yeah. It's worth trying.
All right.
It's
It was like I said. I made it so it made things 7 times more difficult in switching screens, and I didn't like it. I didn't like it.
yeah.
But I'll see if. But I'm sure they're gonna want more money from me because I gave them like $400 or something for a license of it, and then OBS
Yeah.
is free. So, um, I'm gonna say hi to a bunch of people. Whoa, can I? That's
I
weird.
don't know what happened.
I don't, it doesn't give me the chat button, the participants button. Did I just make the thing too small? Oh, there it is. Okay. All right. Hello to Ambuj Bhaskar, Beth Johnson, Bort Klankar, Carolyn B., Daniel McCool, Gordon Dewis, Guido Bibra, James Aberson, John Suffield, Magnus Thymer Jensen, Michael Bommett, Mrs. Nat. Hey, Nightbot's finally there. Paranor, Paul Gracie, Rich Wilson, Rich901, Arjone, Ronald McCoy, Sergusi, Side MT, Umu, Yamagashi-san, and Zapfan. Hello, everybody. Just a piece of news. I am going to be doing a premiere of my new video 15 minutes after Astronomy Cast ends. So on my channel, and it's going to be all about the future of gravitational waves, which is going to be sort of a nice sort of follow-on piece to what we're going to be talking about today, where gravitational waves will feature quite prominently. So after that, you can watch the episode live with me. Have you played around? No, of course not, because you haven't played with the YouTube thing. But the Premiere system, where you can set a time in the future where where it will show for the first time
Yeah.
live.
So I've heard about that. We don't do anything that we're that excited about promoting, but
Right.
where our daily space is basically a daily churn of short
Yes.
videos.
Yeah. Yeah.
That's so totally different from your highly produced, long-term lasting
Yeah. Well,
guide to
the
space.
funny thing is, I tried to do this in the past, and people yelled at me because they're like, I want to see it right now. I don't want to have to wait. I don't want to have to know about a thing that's going to happen in the future so that I can watch it with the creator and chat with him. I want to see it right now.
All right.
So, and so I was sort of put off by the process, and then I did a couple of them this week, and people were like, "Can you give us more notice?" Because I didn't want people to complain, so I gave them no notice. I just the episode was ready. 15 minutes later, let's watch it together.
You're
So
learning that there is no way
no,
to
no,
placate all the humans
mm-mm.
when your audience is bigger than one.
That's right. Yeah, yeah. So I think Rich Wilson is pointing out that premieres are awesome for useful first take feedback. I think that's great.
Yeah.
which is like if you make any really terrible mistakes in the episode, you can quickly fix it, and I think it's a smart way to go about it. So anyway, join me, and I'm sure somebody can put a link in the chat to the premiere of The Future of Gravitational Waves, seeing every black hole collision in the entire observable universe after this.
All right.
And then next week, I'm in shameless self-promotion mode. We've got an episode on, oh my God, I don't even remember. Shadow Biosphere is going to be on Tuesday. And then
Wait, Shadow Biosphere?
Shadow Biosphere, yeah.
So this isn't the biosphere in Arizona.
No. This is the possibility that there are life forms on Earth that aren't related to us.
Okay.
Right?
Okay.
So, we think that everything is completely connected. All life is connected.
Yeah.
But, at the microbial level, there's apparently 1 trillion different life forms on Earth. Almost all of them are microbial. And so we've only really learned about a fraction of them. And so in theory...
Yeah, so I personally love the idea that like cyanogen and methanogen bacteria evolved separately from us oxygen requiring stuff and things.
Right. But I mean, we do share genes in common with them, and they even use DNA. So, so the crazy part is that there could be critters, microbes there, but all of our machines are designed to test for DNA and RNA and proteins and things like that. And so
Yeah.
it's a tricky thing. And then the other video is going to be about abort systems. So
Okay.
thanks to Crew Dragon. And one of the viewers suggested a topic. Wanted to know if there's a way that just an astronaut could get back to Earth by jumping out of the space station. And
sort of.
Well, short answer, no. But NASA did consider almost like you would wear a heat shield on your suit, and it would be it would pop open and have foam that would encase you in it, and it would be in the shape of a heat shield, and then it could re-enter the Earth's atmosphere, and then it would turn into a life raft when you landed in the ocean. It would have a parachute, so it would all be sort of on your suit. So
and there was that crazy Red Bull skydiver a number of years ago.
Right, but he wasn't going 28,000 kilometers per hour sideways.
No, that's true. That's true.
Yeah.
That's where the whole sort of comes in.
That's exactly it. Yeah. All right. So if you're wondering what it is that you've stumbled into, this is not Let Fraser shamelessly self-promote his upcoming videos. This is a live episode of Astronomy Cast. Yes. I'm Fraser Cain, publisher of Universe Today. That's Dr. Pamela Gay, director of CosmoQuest. And today we shall be talking about multi-messenger astronomy. Are you ready?
I think so.
I gave you like 10 minutes to make sure that your recording system was going to be all
that
warmed
stuff
up.
is ready. I'm just having a brain day. We haven't had water in 2 days. In the house?
Like
we had a water main break.
Oh no.
And so everything's just been a little squirrely.
Oh God.
And yeah.
I had one. I had the I don't know if you remember a couple of years ago, but 2 years ago I had the water main go to my house.
Yeah.
In December, January. It was a nightmare. Is it the main city street one, or is it the one actually to your house?
No, there's like this whole large area where we have water will come out of your faucet. You do not want to interact with this water.
Yeah.
Kind of foil warning.
Oh, yeah. Yeah, I was able to steal water from my neighbor. Just took my hose up from my house to his house, and then I was able to borrow the water until we could get ours working again. But yeah, it was a nightmare. Okay, so let me know when you'd like to press record.
I am pressing record.
I have also pressed record.
It is recording on the correct device.
Okay. Hello, Susie. Enjoy.
Hi, Susie.
Astronomy Cast, episode 556, Multi-Messenger Astronomy. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Doing great. Though apparently you don't have any water.
I don't. We had a water main break here in town. There's a winter storm going on and everything went just a little bit sideways. But this is why you should always keep several days of water in your pantry. And when you're done with a water emergency, just refill the containers with clean boiled water and you should be good to go for the next emergency.
We have a water boiler that we
Uh-huh.
use for our tea, and
Uh-huh.
so when we're having those advisories, we just run that thing and fill up with water and put it in the fridge. Although it's probably not safe. Like it's not a rolling
No,
boil
you're
for.
supposed to boil for 15 minutes and those
Yeah,
will boil for like 2 seconds.
yeah, exactly. And then and then cools back down to a little bit lower temperature. But
A tamale steaming pot filled with water,
yeah,
I highly recommend.
for the longest time, astronomers could only study the skies with their pathetic telescopes. But then new techniques and technologies were developed to help us see in different wavelengths. Now astronomers can study objects in both visible light, neutrinos, gravitational waves, cosmic rays, and more. The era of multi-messenger astronomy is here. All right, Pamela, I've been seeing this term, multi-messenger astronomy, more and more recently. So can you help people understand what is it?
Well, it's not new. So let's just start with that. So the first big multi-messenger discovery that people really point to is supernova 1997, 1987, 97.
1987A. Yeah.
1987A, which was detected in neutrinos as well as in light. Since then, the reason that we're now hearing about this so much was the neutron star merger that occurred in 2017. So 30 years later. And that particular discovery, which I've heard estimates of 1 in 10 astronomers to 3 in 10 astronomers in the world, depending on how you count astronomers, worked on that particular discovery. Well, that one was detected across gravitational waves, all kinds of the electromagnetic spectrum. And with so many different kinds of detections going on, with so many different people, this, of course, started everyone talking about multi messenger astronomy and also asking, hey, can we have funding dedicated to what we've been piecemealing together on our own? So now we're starting to see these funded, coordinated efforts where you have high altitude cosmic ray detectors in Mexico working in coordination with buried in ice neutrino detectors in Antarctica in combination with gravitational wave detectors spanning all around our planet to together try and understand our universe.
And so, like when radio waves, microwaves, visible infrared, X rays, gamma rays, that's all part of the electromagnetic spectrum. And I mean that kind of work has been done for decades, that you will look at something in both radio waves and in visible light,
And we call that multi wavelength
multi-wavelength, because it's essentially still just the same thing. It's just
photons.
photons, right? And so you're only really seeing it in one dimension. So can you explain? I mean, it's useful, but can you explain kind of why it's not as useful as starting to bring these other technologies on board?
Well, at the end of the day, thanks to this whole E equals MC squared thing, we are able to have energy and matter transition back and forth in different ways through different astrophysical processes. So if you have a good old happy hot star hanging out somewhere in the universe, it's going to be generating light in a whole variety of different colors. And those colors are a function of what temperatures the star, and if it happens to be flaring or doing something particularly dramatic, you may get physics that is also on top of that generating X rays,
Right.
gamma rays, high energy events. But in general, a nice, good old fashioned black body radiation is what we call this warm object star. hanging out is just going to be giving off photons of light that we can detect here on Earth. And by looking at different parts of the electromagnetic spectrum, we're probing different kinds of activities. We're seeing everything from how the atmosphere of the star is absorbing out different colors of light, telling us, well, what's the composition of the star. We see radio signals that are starting to tell us about the environment around the star. Everything's a different physical process and a different piece of information.
Right. And at the end of
That's
the
awesome.
day, photons are photons.
Exactly.
And so in most circumstances, you're going to see this nice, smooth black body curve that you would expect to see. And then, as you said, if you get like auroras on Jupiter, then you might get a burst of X rays. Or if you're seeing some kind of radio emission from some magnetic field reconnection on the sun, then you're going to get something else. But so let's talk about what are the avenues of what are the new other ways that we can perceive the universe. And we sort of quickly went through a bunch of them, but let's take some time now and talk about what we've got, what astronomers have at their disposal.
So with photons, we're using the electromagnetic spectrum. With other things, we're still able to do that to a degree. So muons, for instance, they're a kind of particle that gets formed in our upper atmosphere when high energy particles hit the atmosphere. Energy gets turned into a particle, and those particles get detected at the surface of our planet, um, thanks to how they interact with different electronic packets, basically. You can go to a variety of museums, see these setups. A flash of light will occur when a muon hits the system. And what we're seeing here is okay, something with a lot of energy occurred at the top of the atmosphere, created particles. Those particles went at close to the speed of light, changing their own experience of time as they did so until they interacted at the surface of our planet. So this doesn't give us a lot of information about where the particles came from. And this is actually something that you're going to hear me repeat. So we can detect muons at the surface of our world. That's cool. We know there's cosmic rays because we see static on our television set when we're taking images with a CCD or a CMOS chip. We'll see these bright blown out pixels. This is from particles either generated in granite and other slightly radioactive rock that's coming up from the planet, or it's created by something that made it through our solar system's outer boundary, traveled through the solar system and traveled through the
Right.
atmosphere and made a mess of itself.
I've got an analogy that I like to use with this is that it's kind of like watching fireworks, especially if you're like
Yes.
underneath the fireworks. And so the firework goes off and you see the bright flash
Yeah.
of the actual firework itself. And then you might see other flashes of other sub parts of the firework go off. But if you're close enough, and if you've ever like I don't know shot, being close enough, you can like sometimes like dust will fall down from the the fireworks, which is just like the particles that are made up in it will rain down, and so now you've got like sort of two separate pieces of evidence that a firework went off. You're seeing the light, but you're also feeling the particles that are landing around you. But then you also can hear it. You can hear the sound waves from the firework that are coming from it. And if the you know when if you had a really precise seismometer, when those booms are going off or when the firework is firing, it will be shaking the ground and you would be able to detect the motion of that. And each one is like almost like a completely different way of sensing that these fireworks are happening. And it's all, each one tells you more information about what happened, and they're all independent, which is the key here. So cosmic rays are like the
That
toughest one,
dust.
right? Yeah, but
Yeah.
they're the toughest one to be able to like we don't know still what's really causing the most energetic of these, right?
Well, and I can continue your analogy, but before I do that, and Susie knows she needs to cut this out, Susie's texting me that you need to fix the chat on screen.
Oh, sure.
So to continue with your analogy, that dust that's hitting you, it's been blown by the wind, it's been caught in various updrafts, it's interacted with birds' wings in some cases. And all these different interactions that the dust experiences between being generated in that firework burst and dusting you, those hide where it came from. You can't trace back
Right.
the path to figure out exactly where the fireworks occurred. And with cosmic rays, these are charged particles. As charged particles move through the universe, they're going to encounter a myriad of different magnetic fields. And each of those different magnetic fields is going to deflect that charged particle one way or another of our planet. Well, we have no idea where they came from.
Right. Like there are particles that are striking the atmosphere or hitting space-based cosmic ray detectors with an enormous amount of energy, and we don't know, like a baseball, the amount of a fast thrown baseball, and we don't know what's causing them.
And they're kind of a bear to detect because on one hand we see them in our television screens, we see them in our detectors. I currently, because I have a bad cable, see them all over my monitor. But at the same time, purposefully measuring them in a systematic way that allows you to measure the individual energies of these suckers is hard. And there's a whole research team dedicated to trying to study them using a high altitude water shrink off experiment. This is called HAWK, and it's located at the Parque Nacional Pico de Orizaba in Mexico. And apologies for my pronunciation. And this is essentially a super picturesque field of water tanks with a volcano covered in glaciers in the background. And this high altitude location, because cosmic rays do interact with particles in the atmosphere, allows them to detect more of these than they would at the ground. And by looking at how the cosmic rays interact with the fluid in each of these containers and produce sparks of light in the process, they're able to start to get a grasp of the diversity of energies that are being captured in these cosmic rays.
So let's talk about neutrinos, which are a little easier to spot. A little.
So I have to hem and haw with that one.
At least to know where
And
they're
and
coming from.
sort of.
Yeah. I mean, we
So
saw them
so
come from a supernova that was in the Large Magellanic Cloud. We know they're coming from the sun.
well, and the way that we're able to start to get at direction, sort of, kind of, maybe, is by detecting bursts of neutrinos at multiple detectors on the planet and looking at the light travel times. We can't always do that, which means that when we look at things like the 1987A discovery, we're looking at a coincidence factor
Right.
of
We saw a
when in
blast of
time.
neutrinos, but we weren't sure they were coming from that same direction.
We had no idea where on the sky they came from. But due to the coincidence in time of the supernova going off and seeing this overabundance of neutrinos, that tells us that the neutrinos are most likely, well, in this case, we're saying the coincidence actually does mean that the two things are related.
Yeah.
But any one given neutrino, just like with cosmic rays, we have no idea where any one given neutrino came from.
Right, right. One interesting thing is like the new like Ice Cube, which is that sensor that's down in Antarctica. It's big enough now that they can detect essentially the cascade of particles moving through their detector array and get a sense of roughly where it came from. But you've only got sort of that one facility. You don't have necessarily multiple facilities, one in the South Pole and one in the North Pole in Greenland or something. But they're working on a new version. Like it's a cubic kilometer of ice, but they're planning on
Right.
building a 10 cubic kilometer version, which will be even more sensitive. So we might get to this point. But right now, right, the only neutrinos that have ever been confirmed are the sun and supernova 1987A.
And so there's that theoretical if we detect them in multiple places. And then there's the reality of each neutrino tells its own story, and it's not telling that story to us.
Right. But you can see tons of room for improvement on that field as we get bigger, better neutrino detectors operating with more sensitivity and being able to line them up with the supernova explosions that are happening in farther and farther distance. There's a network, a supernova detection network that you can sign up for and get announcements that never happen for neutrino discoveries.
and and one of the crazy frustrating things with so much of this is cosmic rays and neutrinos are both really good at passing through stuff. You and I currently both have a myriad of different particles passing through us. And in general, this isn't a huge deal, but where it's not a huge deal to us that we have them passing through us, it becomes a huge deal to scientists who are like, stop. I want the particles to stop so that I can sense them. And we put cosmic ray detectors at as high an altitude as possible so that we can catch them before they interact with the atmosphere. With neutrino detectors, we bury them as far down under the ground as we can to get rid of the cosmic rays, because cosmic rays are more or less stopped by soil. They're also generated by granite, so don't build your neutrino detectors near granite. Uh, the neutrinos, on the other hand, are like, yeah, I'm just going to pass through the planet. No big deal. I'm fine with that.
This is a completely separate rabbit hole, but did you hear that they are starting to detect neutrinos coming from the Earth?
No.
Yeah. So apparently, radioactive decay in the Earth they've caught like 50 neutrinos that came from the Earth itself, which is just absolutely fascinating. So maybe there could be multi-messenger geology. Anyway, so let's talk about the most recent and exciting advancement, which is of course in the whole field of gravitational waves. So what ability do we have to be able to sense the direction of gravitational waves?
So, gravitational waves, luckily, the way that we detect them automatically gives us a certain amount of directional information. Gravitational waves are so small that what we're detecting is a less than a proton in size fluctuation across great distances in um, the path of a laser beam. So each of these LIGO, Virgo, whatever they are, gravitational wave detectors, has sets of mirrors and a laser beam, and they're creating a pattern of interference. And when they see that interference pattern change, that means something has changed the distance. Now, the issue is that something could be geology, car going by, so many small factors at the level of sufficient rainfall will change the gravitational pull between 2 points and drift them apart. These are hairy matters to try and correct for. So, in order to say, yes, I saw a gravitational wave, they have to see the same detection across all the detectors that are up and working. And they need to have a consistent timeline that allows them to triangulate where on the sky this gravitational wave should have been coming from. Now, this isn't a super high resolution. It came from that area less than the size of the moon on the sky, but it's currently enough information, just like we used to have with gamma ray bursts. It's enough information that we go, zoom, everyone looks at that section and looks to see, is there a supernova in that section? Is there some other transient event that wasn't there before that we can blame this gravitational wave on?
Yeah, it's definitely not down to the point that it's like the size of the full moon, but it's not bad.
No.
There was a recent discovery of gravitational waves that came from sort of in the region of Betelgeuse, and the astronomers knew with a level of precision that was roughly kind of sort of in the direction of Betelgeuse to within a few degrees, enough that one of the astronomers was like, I'm sure it's not real, but I just looked out the window just to see if Beetlejuice was still there.
And as a reminder, the moon is less than a degree across the sky. So we're talking several moons of
Yeah.
sky.
But
But
that beats the previous. Like before, when it was just LIGO,
exactly.
you only knew really the hemisphere. It either came
Yeah.
from the left or it came from the right. And then Virgo gives us this level of precision down to kind of over there ish.
And every gravitational wave detector we add to the planet increases our accuracy, increases our ability to say, okay, so now we have all these different vectors. And the only way to work out these timings is that spot right there. And this really is where we started with gravitational wave science. Not gravitational waves, sorry. Susie edits. This is really where we started with gamma ray burst science, where we were able to say, oh crud, there was a burst of gamma rays from somewhere, and we couldn't even initially say if it was above the planet or on the planet.
Right.
And then we got to the yes, this is of cosmic origins. And now we've gotten to the bam, bam, bam. We are identifying all of them that have a visibly optical component with them. And that's just awesome.
Yeah. Yeah. Um, so, so what I'm sort of one of the things that we've talked about many times in the past is this idea of the cosmic microwave background, which is of course the electromagnetic, the photons that are in all directions, which are the afterglow of the Big Bang. Could we take these different multi messengers and try to map out something similar in their ways as well?
Well, there's a lot of people trying to figure out if we can use gravitational wave science to get at a gravitational wave background that might allow us to start to get a sense of primordial black holes, of other exotic physics that we just don't have any other way to prove or disprove. But the sensitivities required are beyond what we can put on the surface of our planet and probably beyond what we can put in orbit of our planet. So, what's theoretically possible and what's actually possible are two very different things. And so, yes, in theory, we can start to probe our early universe with gravity by
And
looking at these small distortions. But we need to get good at measuring things way smaller than protons, way, way smaller than protons.
right, and then the other idea is potentially there could be a neutrino background, cosmic background, which there would be a lot of neutrinos generated during right after the Big Bang, right?
Well, and here what we're talking about are the theories that relate to why we live in a primarily regular matter universe and why the matter and antimatter didn't completely self annihilate during the Big Bang. Uh, Neutrinos seem to play a role in that. We're not entirely sure what role, but they may be out there waiting to be detected, allowing us to finally start to figure out some of these kind of ridiculous mysteries about how we got here. The fact that we don't know why matter dominates. It's just one of those things that it's just like, I'm sorry, we can explain so many other things, but why we're here, yeah, matter's a mystery.
So, I mean, how do you think this is all going to start to play out as I mean, have the different kinds of astronomers been in their own separate camps for the longest time? You've got the neutrino people, and they're more like particle physicists. They're not
Yeah.
necessarily astronomers. They're looking in tanks of water as opposed to looking in the sky, although they know where the particles are coming from. The gravitational wave astronomers, they're like listening to the ground. They're like geologists, but really, of course, they're watching the Earth flex, the space
Right.
time. So, do you see them more and more having to work together and come together? Is there a future of sort of like people who cross train across all these different techniques?
Well, it's going to become both a question of funding and sociology. On one hand, funding calls are generally pretty focused, where they're looking for people who are doing specific kinds of science. But NSF's starting to recognize the power of multi-messenger astronomy rather, and doing specific funding calls saying, hey, we're looking at multi-messenger science and how to promote this and start doing this interdisciplinary science. Now, the other question, like I said, it's one of sociology. When you look at, well, large collaborations in particle physics, they make large collaborations in astronomy look tiny. There's thousands of people on discoveries like the Higgs boson, the top quark. And it's because you have all the high energy theorists, experimentalists, engineers, computer scientists, all working together to create these massive facilities that are multinational because they cost billions of dollars and make JWST look cheap. So now you no longer have the same sort of basically tiny collaboration that astronomy was initially built on. And this is a culture change. And it's one that is slowly being forced upon us. We began to see it with how the Planck mission did, and before it, WMAP did high energy astrophysics and microwave astronomy. We started to see it with the Sloan Digital Sky Survey. But even with the Sloan Digital Sky Survey, while some of the massive catalogs that came out had huge author lists, there's still myriad papers with 1 to 5
Yeah.
authors. We're moving towards a future where that 1 to 5 research person project is no longer going to be possible because that small a number of people can't hold all the knowledge needed to creatively understand the science.
Right.
Like building a house, you need a plumber, an electrician, an architect, a woodworker, a steel worker.
So it's going to be like a heist movie where you've got to bring in a neutrino researcher to help you understand the gravitational waves that you're looking at. I love
But
it.
instead of Ocean's 11, it's going to be Aerospace 542.
Right. Well, I think the Kilonova discovery with thousands of people on that paper gave you a sense, and it was sort of the perfect versions. You had the gravitational wave researchers coming together with the electromagnetic wave researchers in every wavelength, people from every telescope, every observatory, all working together produce one result. And I loved sort of the way that whole thing came together.
And we have to point out that the way it came together was due to gossip and Twitter, where you have different people saying, "Oh my God, we had this thing," and other people going, "We had a thing too." and,
What did you guys find? I can't say.
and these kinds of systems where you have computers automatically tweeting things out, you have
Yeah.
people talking to one another. This is how we realize that multi-messenger astronomy exists, and it's facilitated by doing open science.
Yeah.
And LIGO's kind of known in the past for like, we shall keep all results quiet because there shall be a press release and potentially a Nobel Prize. But now they're moving into having their detectors automatically send out all results.
Yeah, you can have them
allowing
come to
this
your phone.
follow-up. Yeah.
Yeah, you can you can know when, and then it's your job to follow up and see, do you see is Betelgeuse still there? So
So open science is the way of multi-messenger
Totally.
science, and it's an exciting new future.
Well, Pamela, thank you so much. We'll see you next week. But before you go, do you have some names for us?
I do. Sorry, I rearranged windows because I was really bright as I am again. Okay, Susie, things you need to cut out. I suck as a human sometimes. Okay, yes, I do have names I need to read out. And that first name, followed by many more, we have Jordan Young, Burry Gowan, Frade Tenenbaum, Ramji Anamathu, Andrew Palestra, David Troig, Brian Cagle, The Giant Nothing, Laura Kettleson, Robert Palasma, Paul Jarman, Les Howard, Corey Diwali, Emily Patterson, Joss Cunningham, Frederick Hogney, Kvam Jensen, and the infinitesimal ripple in space-time.
That's awesome. That's a great name. Thanks, everybody. Thanks, Pamela. And we'll see all of you next week.
Bye-bye. But stay. stay.
Yeah, that's just the show. That's not really what we want you to do.
Okay, and now we save.
What did I say? 556.
Mm-hmm. I have sleeping dogs all around me.
Save. My hard drive is almost full. I got to dump all the. I just like save up all the detritus of all of my recordings, and they just keep filling up my hard drive. And then every 6 months or so, things start to break on my computer,
Yeah.
and I don't know why. And then I'm like, oh, because the hard drive is full again. Because I've got like a SSD, a really fast SSD as my
Yeah.
main drive.
I appreciate that you moved because I've been trying to figure out what your shirt said the entire episode.
Oh,
Because
really?
all I saw was an S and part of an E. So you have a Paul Matt Sutter shirt on.
No, this is
Wait, no, that's
OPT.
OPT.
Yeah, this is
Yes,
Tony Darnell and Dustin Gibson
Dustin.
from Oceanside Photo and Telescope. Speaking of which, we got Skyless and I fired the old telescope up a
I
couple of nights
heard.
ago and got it going again and took some great pictures. So
That's awesome.
I think we're almost ready to keep. I think to start like looking at dates and going, here's when there will be a new moon. So
I have had crap weather
yeah.
2 months.
Oh yeah.
And I have a telescope to review. And they're like, we'd like you to mail it back. And the last response I got, I actually sent a screen capture of our weather.
Yeah. This was
It's
that the is
like
that the Stellina?
Stellaris.
The,
Yeah. Or you're right, Stellina.
yeah, yeah. Have you
I
even tried it yet?
I winter storm
I know.
advisory.
I know. I know.
It's been so like the couple of nights we had clear skies, it was so windy. I
Yeah.
wasn't going out there.
Yeah, I warned them. They sent me a copy of this thing, right? And I warned them. I'm
Mhm.
like, you might as well just like send it to the bottom of the ocean because that's where I live. Um,
Yeah,
and
Midwest
yeah,
sea level.
yeah. And
Yeah.
so I got a couple of nights that I got a chance to actually play around with it, but I feel bad that I couldn't give them a really full review, and they're like, there's other people who really need to use this telescope, and so I sent it
Yeah.
back to them. So
Yeah.
my review, and I'm sure your review is going to be very similar, which is just like,
Goddamn weather.
yeah, weather,
This is not a fault
yeah,
of the
yeah,
telescope.
yeah. In fact, OPT sent me this telescope. It does not
Hmm.
get used, right? What's the point?
Yeah.
Thanks, OPT. It's a great prop in the back of my live streams, but I just don't get a chance to be able to use it.
Yeah. I'm gonna start using mine if it ever gets clear again.
So people are noting in the chat the first episode of Picard. Did you watch it yet?
I haven't I was afraid it would be bad, and then I saw Phil talking about it last night, and his review was like, okay, I can go watch this and it won't break my heart.
Then do you want mine?
Yeah, go
Meh.
for it. It was a meh.
Yeah. Like it's promising. There was a couple of things that were super weird. And I know I don't want to spoil it, but maybe when you're watching the episode and there's a moment where Picard wakes up and he's on a couch, you've got to ask yourself, what is the sequence of events that had him, that's where he woke up? Seems kind of weird considering what had just happened. I can think of a million places that would make more sense for him to be than on a couch. So,
Okay.
apart from that, it's too early to tell, really. I mean, and like, what can you do, right? Like Jean-Luc Picard, Patrick Stewart, is Baby Yoda, right? So you're just like staring dreamily at the fact that Star Trek is happening again, and you're seeing Jean-Luc Picard. Amazing. And so
Yes.
you just take that in, and it's just so great. So
Okay.
the nostalgia is overwhelming. Yeah, Fraser's picky. I am picky. I'll pick
I
it.
will say, while I wasn't a fan of the first season of Expanse, I am now a fan of it as they
Good.
go into season 4 and they're
Okay.
creating new content beyond what was in the
Well,
books.
it's still in the book apparently.
It's not totally in the book.
Yeah, Carla knew how everything was going to turn out because she's read all the books.
Okay,
So
there may be books I haven't read then.
yeah, there's I think there's still just a couple more at this point now, and then they'll be
Okay.
done. But I loved season 4, and of
Okay.
course everyone knows that I thought the Mandalorian was mediocre. They,
So once I got past episodes where I'd read the books, I liked The Expanse.
right.
I was just
Yeah.
displeased at the ones where I'd already read the books. So that may say
Yeah.
something. The books are amazing.
Yeah.
But
Well, I totally want to read them. They're on the list. Like I don't know about you, but I just have like I don't understand how anyone ever says that they're ever bored.
I know.
Right? I have a lineup of 1,000 for like again, I have like whatever 1,500 games in my games library. I have a stack of books like this
Yeah.
sitting. I have a bunch of books back there.
Yeah.
Um,
Me too.
you know,
Behind all the
yeah,
stuffed animals are
podcasts that
books.
pile up, music to listen to, TV shows to
Yeah.
watch, and I it's crazy, yeah, how much stuff there is to watch. Fraser would man almost everything. No way. There's a lot of stuff that Carla and I we watch a ton of television and movies. So you're not hearing all the stuff that we love, but most of the stuff that we watch, thanks to things like Rotten Tomatoes and the Internet Movie Database, I get to just watch stuff that is 99% on Rotten Tomatoes. It's good.
What's fascinating though is the stuff where you get completely bipolar reactions. Like The Witcher was either loved
I
or
loved it.
hated.
I love The Witcher.
I've determined I have to watch it again because I watched it while distracted and couldn't figure out anything.
Yeah.
So
It's well
I
it has 3 separate timelines, and
yeah.
it doesn't pull any punches about what's going on. So yeah, no, but I love The Witcher. And I love the game, and so I was really prepared for a letdown because
Did you read the book?
no, I haven't read the books. Yeah.
Okay, so again, read the book.
Right.
Didn't help.
Yeah.
It was just
But like when has a video game, movie or television show ever turned out okay? It's always gone terribly. And so taking a game that I really enjoyed, but I guess that's the point. They went back to the book, and then they went from there, which is I
so
think the
did
smart move.
what was the order? Book game or game book?
Book game. So book
Okay.
book
Okay.
game, and so if you like follow the tree, the
Mhm.
the book, the game, and the TV show share a common ancestor of the book,
Okay.
but they're not related to each other.
Okay.
Although obviously they took inspiration with, the character for Geralt. So,
Yeah.
but no, we watch a ton of great stuff. Although like we'll watch like a lot of, well, what I do, I've mentioned this in the past, that I use the service called Just Watch, and then I will see all the new shows that are coming on this. Yeah, it's called Just Watch. Let's see if you can see this here. I'll try and share my screen, or I'll hold my phone up to the screen. So I have a watch list for all the shows that we get, and then
And
anything
it
that I
says where it
yeah, and it
is.
just says where it is. So apparently, so the thing that I am supposed to watch now, according to Just Watch, is Vikings, because I haven't seen Vikings. Carla's seen Vikings. There's a lot of she watches more than I do, and then I should watch Downton Abbey, and I have seen The Expanse, and apparently The
Those are
Magicians.
very disparate, different.
Yeah, The Magicians. Fleabag we're caught up on. I should see Succession. We're catching up on Doctor Who, Shameless. So there's a lot of stuff that we should watch, and then a ton of movies too. So we've. It's kind of surprising how much of just stuff we've watched, and just from Netflix and Amazon, it's amazing how much there is to watch just on those two
Oh yeah.
services. Like you'll be busy for your whole life. We should answer like a couple of questions.
It's true. We're
Yeah.
totally babbling. This
Yeah.
happens, folks. I'm sorry.
Yeah. I'm not.
We both work from
Yeah.
home, and this is like our time to randomly babble with
Unc Willie
somebody
asks,
else.
does LIGO share its geological data with the USGS, with the U.S. Geological Survey?
I suspect it may actually go in the opposite direction,
Mm-hmm.
where they're drawing that data from the USGS.
I mean, I'm sure, like they take into account trucks moving, but
Oh yeah.
but the point is that that's why you have two facilities. That
Mhm.
if you get a shaking in one facility and not a shaking in the other facility, then it's a truck, then it's somebody dropped a book in the facility, right,
Walk
etc.
softly.
Yeah, exactly. Arjone asks, will a third gravitational wave observatory allow us to pinpoint gravitational waves anywhere in the sky? Where would that have to be? We're already
Uh,
there with three.
yeah, yeah. Because there's the European network, and then they're putting another one in India. So where it's going to go from is the error bars put it somewhere in this swath of sky to it's in this swath of sky to it's right there.
This is a great. Rimble on Twitch asks, now that we've recorded gravitational waves, how long till we can create them on demand? It would make long flights, space flights, more bearable.
I don't think we want to be releasing that amount of energy
Well, we
close to
can
the Earth.
look, just wave, and you're releasing gravitational waves. You did it
But it's
on
not enough
demand.
to shorten airplane flights.
Right. Yeah, no, then you would need to be crashing black holes together. Well, not they're talking about space flight. So,
Still think there's
yeah.
better ways. I want to figure out how to get into those other dimensions that are all rolled up.
But
We can just tunnel through those extra dimensions. We're good.
yeah, yeah. But in theory, is the warping of space-time via gravitational waves the kind of way that you would want to travel? I don't think so, because like if you were close to a black hole collision and the gravitational waves were passing through your body, you would be torn apart. So that is not stretching of space-time in the good way.
Yeah. Yeah.
So you want the kind where space is compressed, you step over, and then you're in the new spot.
Yeah. Because the problem is the individual atoms and molecules are held together through other forces that are stronger than gravity.
Right.
So when you change the space time, those individual things,
Yeah.
they stay together and the distances between them change. And
Yeah.
badness.
Yeah, I've gone back and forth with some scientists on this one, and the consensus is, yeah, if you were close enough, you would get torn apart. But if you're close enough, then being torn apart by space-time
is the least
least of your problems.
Yeah.
Yeah.
Where we are, the bonds between our atoms and molecules are greater than the stretching effects of gravity.
Arjone asks, were any neutrinos from supernova seen since 1987A?
I think so, but I could be wrong.
I don't think so. There was one in 2014, supernova 2014, I forget the number, which was the closest supernova since 1987A, and they didn't see any neutrinos from that supernova. So they've seen them from 87A, they see them from the sun, they see them just randomly, but they didn't see any with the most recent one. And that was sort of the joke I was making in the episode, which was that there is a supernova warning network.
And
it's never gone
you
off.
don't ever hear anything.
Right. But
yeah, that I knew. This goes back to the fact that we're kind of owed a supernova.
Oh, yeah.
Supernova 1987A was in the Large Magellanic Cloud, and we haven't had one in our galaxy, in the part of the galaxy that we can observe, in a couple hundred years.
Yeah, I hope that Betelgeuse is feeling really guilty at this point.
Oh, it should be.
Yeah, and it needs to just step up.
I am mocking it.
Yeah, it needs to step up and do what's necessary for science. Oh, but as
But
Elad Avron is saying, we're not going to see it, are we? No, we're not.
did you see the release on 2000 Supernova 2006 GY? This is my new favorite supernova.
Yeah, I'm really thinking of doing a video on that and the new evidence that it looks like gamma ray bursts require a companion as well.
Yeah, yeah.
Yeah, but just imagine you've got this giant star with a white dwarf, and the white
In
dwarf
the star.
falls into the envelope of the star and then
Well, it didn't
spiral.
fall in. The star expanded around it.
Sure, potato potato.
I I'm going to be writing an article up on Medium later today, so
Yeah.
I'll tweet out a link.
Yeah, yeah. And then fell into it and
Yeah.
then reached the core and went kablooey, and then the whole mess went off.
Yes.
Just
Yes.
imagine what the forces and the chain of events. Like did it go off as it entered the envelope? Did it go off as it was nearing the core?
That is what they're saying.
So it reached the core and then it exploded.
Yep.
Yeah.
And it shut its envelope as it went in.
Crazy.
Yeah.
Yeah.
It's awesome.
Yeah. And that was the most powerful supernova that's ever been seen.
But it still counts technically as a supernova type 1A because it was a white dwarf that
Right.
was overcritical.
Right.
So it's one of the brightest supernova ever, and it's classified as a standard candle.
Yes. But imagine if did the star survive?
I need to finish reading the paper
Yeah.
in detail. I did a quick read of it earlier, and then Bad Panda Bear asked me the same question earlier today, and I'm like, oh, I missed that part.
Yeah.
I was too excited about the fact that it got consumed.
Yeah, and so the other piece of research, as I was saying, was that you've got these binary or some kind of probably like a star or a white dwarf, and then you've got a companion star, and the two collide, and that helps set off the gamma ray burst and helps create those collimated jets that whip up the magnetic field of the gamma ray burst as it's coming together, and you get the jets that are
I didn't think they needed to collide. I knew it was the transition of angular momentum. So essentially, the companion star
okay. Yeah, maybe they aren't collided. It's just you're getting that it whipped
it's a
up.
transition of angular momentum. So
Right.
so as the supernova is going off, transfer of angular momentum from the companion star.
Right.
Since the companion star flying out of the system
Right. Okay.
generates the jets, and this means that Eta Car could create a gamma ray burst, but Betelgeuse, which as far as I know is a singleton,
Right.
Betelgeuse can't create a gamma ray burst. But Eta Carina, if it goes gamma ray burst, is pointed away from us, so we're good.
Right. But then could be some mysterious star halfway across the Milky Way, and it could hit us. So even if one went off in Andromeda, it would be bright.
As long as it's more than, I think it's 7,000 light years away, we aren't going to die.
No.
It's just going to be cool.
No, it's like 100,000 light years away for a gamma ray burst. If you get hit by the beam.
Okay.
Yeah, or 50,000. It's halfway across the galaxy.
Okay.
So
that sucks.
Yeah, while a regular supernova, it's 30.
Okay.
So if you're farther than 30 light years away from a supernova, you're fine. But with a gamma ray burst, it can be 50,000.
I was much happier when I had the wrong number in my head.
Yeah, Phil did a bit on this in Death from the Sky, so definitely check it out. I don't know if the number has changed, but yeah, it's pretty scary. Okay, we've reached.
I remembered the number from his book.
Yeah. All right, so we have reached the end of the episode, and like I said, in 15 minutes, I'm going to be doing a live premiere of my new episode, all about the future of gravitational wave astronomy. So it will tell you exactly when we will be able to see every merger, everything in the future of the universe. So definitely check that out.
Sounds good.
All right. Thanks, Pamela. Thanks, everyone, for watching us today. Thanks to all of the moderators for posting questions so we could actually see them. Thanks to Susie for the future editing of this episode. And we will see all of you. When's the next thing that you're doing a thing?
We are going to be covering the launch of the next batch of Starlink satellites whenever that finally decides to take off, which is currently slated for tomorrow, unless they changed it since I last looked.
Wow, it's been so long since we've had a batch of Starlinks go up, like 2 weeks. But this is what every 2 weeks feels like. There's a new launch every 2 weeks, so buckle up.
There's actually a new launch of something several times a week. It's really kind of
Yeah,
amazing. And last year, China launched way more than the
yeah, I
United
know.
States did.
Yeah, yeah, they were well, not way more, just a couple more, but they are the largest launch provider in the world, which is just
Yeah.
incredible to think. All right, thanks everyone, and we'll see you all next week.
Bye bye.
Press the button.